Okay, it's 1 o'clock, so let's go ahead and get started. All right, good afternoon, everybody. How's everybody doing today? Doing good, hopefully. It's Thursday of week 10, so it's definitely that time. So, we have our midterm next week. So I believe we talked about it a bit before. And so today's lecture is going to be the last topic that's going to be covered on that midterm. So inflation is going to be the last topic. It's actually going to be our last day on engineering economics too. So starting on Tuesday of next week, we're going to start up on ethics, which is going to be what's going to be the subject of the rest of the semester. So after today, we won't see economics anymore. Okay, so for the midterm, after the class today, I'm going to post a study guide onto Canvas to help guide your study. I'm also going to put a poll onto Canvas as well. So just like I did last time, I'm going to record a review session that you can kind of view, at your own leisure. And so usually for my review sessions, just like last time, I usually only have enough time to cover maybe 2.5 of topics that we covered. So ever since the first midterm, we've covered actually quite a lot. So make sure you vote in that poll and tell me which topics do you feel most uncomfortable with, just so I can make sure to cover those in the review. Okay. In terms of format, the exam is going to be the same. So I'm going to post the exam at 1 p.m. next Thursday, and then you're going to have 24 hours to complete the exam and submit it by Friday at 1 p.m. Okay. And then I'll be a bit more careful with the timing. So hopefully, this exam will take you less time than the first one. Right. And then I think that's all the announcements I have for the exam. Are there any questions about that, or just anything else before we get started today?
Is there like any certain topic that we need to focus on, because we covered a lot since midterm 1?
Yeah. So I mean, it's going to cover everything pretty evenly from ever since starting with rate of return and then ending with inflation right here. So there's I'm going to try to cover everything pretty evenly, but definitely I think one of the more time-consuming problems that can be there is going to be the tax problems. So just because there's a lot of writing that has to be done with the tax tables and all the calculations. So if you can do the tax problems pretty quickly, that's going to help you with your time quite a bit on the exam. Rate of return also, I know for the rate of return problems that we did in the homeworks, I kind of gave you a hint on where to start looking because I gave you the solution. But on the exam, I'm not going to be giving you the solution. So make sure you get some practice and kind of looking through, the different values on the cash flow table or in compound interest table so that you can kind of do those problems quickly. So definitely, I would, it's, besides just kind of practicing what we have in the homeworks already, it's pretty much going to cover pretty much everything evenly. So if you can do the homeworks, and you understand those really well, you can understand the in-class examples, you understand all the concepts in the study guide, you're going to be in really good shape for the exam. There's going to be no surprises. So definitely make sure you look at the study guide because there's some stuff that's in the lecture notes that we didn't have time to cover in the actual lectures, and if we didn't cover them in the lectures, then I'm not going to test you on it as well. So definitely look at the study guide and kind of cross-reference with your own notes and the lecture notes, and kind of make sure that you're spending your time efficiently studying. Are there any more questions on that? Okay. Right. So let's go ahead and finish it. Oh, I have one more announcement, which I'll send another email for because it kind of applies to everyone in the class. I'm going to open up the sign-up sheets for the final project tomorrow. So a couple groups have already kind of reached out to me, and I know that some of you already kind of know what project that you want to do. So that's great, but just to make sure that it's kind of an even playing field for everyone, I'm not going to open up the sign-up sheet until let's say 11 a.m. tomorrow. Okay? And so 11 a.m. tomorrow, I'm going to send everyone an email with a link to the sign-up sheet, and then once you get there, you can sign up for for whatever project you want. But if someone already has logged in and taken the project, then you kind of have to go on to your next choice and your next choice after that. So definitely, just like I recommended before, make sure that you have your top choice, but then you also have at least 2 or 3 backups, in case your top choice gets chosen by someone else. Okay. And so I'm going to send an email about that. So I'm going to talk about that, once I post the study guide and I put the poll up. But I'll send another email tomorrow at 11 a.m. to open up the signups for the final project. Okay. And so if you can have at least one person in your group, on at that time, just to sign up for the project, I think that would be most ideal. Okay. So let's go ahead and continue on with our lecture notes on inflation. Okay. And so remember, inflation, what we talked about last time, it describes how prices increase over time, right? Because everything up until this point, we've been mostly talking about cash and interest rates and how much present worth and stuff that you have, but we haven't really talked much about prices. And so generally what tends to happen in the economy is that prices for goods tend to go up with time, and that's what inflation is. Right? And so last time we kind of mostly introduced, we defined inflation and we kind of went over some basic definitions. And so today we're kind of going to continue on with that trend. Okay. And so I think where we specifically left off on Tuesday was we left off doing an example. Okay. And so in this example, we have a sports stadium that was built in 1965. Okay. And the cost for this sports stadium was 1.2 million. Okay. And so to kind of invest for a future replacement, an owner invested another 1.2 million. That's going to be, that's going to be stashed in a bank account at an 8% interest rate until 2020. Okay. 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 And so if we assume a inflation rate of 6% per year, okay, we want to answer the following questions. So we did part A last time. So in part A, what we did was we computed the real interest rate. Okay. Okay. And remember, the real interest rate we computed from 8% right here. And so 8% because this was offered by the bank. Remember, this was a market rate. Okay. And then we took that information along with the inflation rate, and we found that the real interest rate was 1.887%. Okay. And so what that means, remember, is that real interest rate kind of tracks how your purchasing power increases with time. Okay. And so this $1.2 million that the sports owner invested, you can say that, because of the interaction between the market interest rate and the inflation rate, the purchasing power, that 1.2 million, is growing by 1.887% each year. Okay. Okay. And so in part B of the problem, what we want to compute is the actual dollars worth of the investment. Okay. Right. When the investment is withdrawn in 2020. Okay. Okay, so the key word here is actual, right? So remember what actual money is. So actual money is that's the money that you can actually physically grab and and spend on stuff. Okay. And so when we're converting between actual dollars back in 1965 and actual dollars in 2020, what we use is the market rate, right? Okay. Because this 1.2 million that the owner invested back in 1965, this was actual money that he had, right? So this was actual money that he could have spent on other stuff, but he put it in the bank at an 8% interest rate. Okay. And so that 1.2 million of actual money is growing at 8% per year. And when he withdraws it in 2020, then it's going to grow by that amount. Okay. And so to compute that, we're going to use our F over P formula. Okay. We're going to do F is equal to 1.2 million. Okay. Multiplied by F over P, right? Because we're computing a future sum from a present sum, or I should say a past sum. Okay. And remember, the rate that we're going to use is our market rate, which is 8%. And then between 1965 and 2020 is 55 years. And so we look this up on the table, and then what we get is $82,701,600. Okay. And so that 1.2 million, that 1.2 million almost grew by 80 times, right? Because now we have $82 million that we actually withdraw. But remember, you know, it's not that we gained 80% purchasing power, because over that 55 years, prices also increased by 6% each year. So even though we have an actual amount of 82 million, that 82 million is not going to be able to buy us $82 million worth of stuff as it did back then. Okay, and so that's going to be the subject of the next part. So before I go there, are there any questions on this? Okay. Okay. And so in part C of this problem, what I want you to compute is I want you to compute the real dollars worth of the investment in 2020 in terms of 1965 purchasing power. Okay. And so if we basically, what we're saying is, if we got this $1.2 million in the bank, you know, how much, if we kind of transported this money back in time, you know, accounting for all the inflation and stuff, you know, what's the amount of purchasing power that this investment would have in 1965? Okay. Okay. So there's actually two ways that we can actually go about this, because, you know, it depends on kind of where our starting point is. Okay. And so the first one that's kind of obvious is that, you know, if we're you know, since we're computing a real amount of money, we can use our real interest rate. Okay. Okay. And so if we do that, we can basically just use the exact same formula that we had on the previous page, but we use the real interest rate. Okay. And so what we can say is that F is going to be equal to 1.2 million. Okay. Multiplied by F over P. Okay. And so instead of the market rate, we're going to be using our real interest rate. So it's going to be 1.887%. Okay. And then 55 years. Okay. And so what this problem is basically saying is that if we left an investment in there for 55 years, but we grew it instead at 1.887%, this is going to represent the amount of purchasing power this investment would have, you know, if we had kind of transported this back to 1965. Okay. And so, you know, obviously there's no compound interest table for 1.887%, and so you'd have to use the formulas here. And so what we get is $3,355,000. All right. And so, you know, what we can basically say is that if we compare this to the original stadium right? And so remember, the original stadium cost $1.2 million in 1965. And so with this investment, we can basically kind of say that the new stadium will be about 3 times nicer, as you can say, because it's going to cost about 3 times as much, okay? So it's just like the new stadium that the Clippers are building in over the Forum. So it's a brand new stadium to watch the Clippers lose all the time. Okay. And so that's the first way that we can do this problem. So basically we're computing, between real and real. And so another way that we can do this is we can take our answer from part B and we can strip away, the effects of inflation, okay?
Professor?
Yeah.
You said that the 1.887 is our purchasing power that increases every year?
Yes. Mm-hmm.
Or that's the rate at which it increases?
Right. Yeah.
Okay.
Yeah, so remember, because we're putting money in at a market rate of 8%. So that the actual money that we're putting in grows at 8% each year. But at the same time, the inflation rate or the prices are going up 6%. And so, the market rate is higher than the inflation rate. So, we're going to be gaining value each year. And so you can think that 1.887% as the amount that the market rate is kind of outstripping the inflation rate.
Gotcha.
So it's not exactly 2% because we have that formula for the real interest rate, but that's intuitively that's kind of how I think about it. Yeah.
Okay. Cool.
One more quick question, Professor.
Oh, say that again. Sorry.
One more quick question.
Sure.
So the 1.2 million that's invested in the beginning. So you're saying later on in 2020 it's going to be worth 3,355,000.
Yes, it's going to be worth that much in terms of purchasing power in 1965. And so remember, for real money, we always have to have some kind of time base to it, right? And so if we kind of took this $82 million that we found in Part B, and then if we compare, if we actually use that $82 million to purchase stuff, the stuff that we buy kind of has the same value as 3.3 million back in 1965. That's kind of what we're saying, because over those 55 years, the prices of things increased by 6% each year.
Gotcha.
Mm-hmm. Okay, and so along that way, that's actually how we actually do Part B, and or the second way that we do this. So the second way that we can do this is we can start with our answer from Part B, which is our 82 million. I don't know why I'm doing this. I have it right in front of me. 82 million 701,600. Okay, and then we can strip away all the effects of inflation for the 55 years. Okay, and so the way that we do that is we can simply just do our 82 million. So we do 82,701,600. Okay, and since we're kind of transporting something into the past, instead of an F over P, we're going to use a P over F. Okay, and so the nice things with all these inflation stuff is we can use all the same compound interest tables as before. Okay, and here we're going to plug in our 6%. And then we're going to plug in 55 years, okay? And so what this will do is it'll kind of remove away, all the effects of inflation that took place over these 55 years. And then what we get from this is the same answer as we got from the first part, which is 3,355,000. Okay. All right. Okay. And so, I give this example because this kind of illustrates our 4 rules that we kind of talked about last time, right? And so remember at the end of last lecture, we talked about the difference between real and actual dollars and how to convert between them. Okay. And so if you look at kind of the first part of this part C, this is rule 2. Okay. So remember, rule 2 is for converting between real and real, right? And so when we're converting between real dollars, to real dollars in at a different time with the same time base, Then we use the real interest rate, okay? And then the second part right here, this is rule number 4, okay? And so rule number 4, we're converting between, real and actual dollars, right? And so in those cases, then we use the inflation rate, okay? And so if you kind of look at this example and kind of refer back to the rules that we talked about last time, you'll see that these are kind of 2 good examples of that, okay? And if you want to kind of categorize part B, this would be rule number 1, okay? And so part B is, we're converting between actual and actual, right? And so between actual, we use the market rate, okay? Okay, any questions on this example? Okay. Okay. And so you can see, from that last example that inflation, can have a really big impact on our calculations. And so, it kind of seems like it's almost like a cop-out that up until this point, we've just been ignoring it, right? But, there's kind of a very simple explanation about, or kind of a convenient way that we can kind of justify the fact that we're ignoring it. And so basically the way that we kind of justify this is that for every one of our problems before, we've kind of been assumed to using real dollars and real interest rates, okay? Okay. And so when we make that assumption, we can have an engineering project that goes on for like 10 years, 15 years, and we can assume that the replacements are going to cost the same, right? Or we can assume that the maintenance costs are going to be relatively the same each year, even despite inflation. Because remember, for real dollars, we're talking about purchasing power, not really, actual cash. Okay. Because in reality, if you have some kind of a machine, and you're going to use it for 15, 20 years, the maintenance costs and the repair costs are going to go up each year. Not only because your machine's getting older, I mean, that's also one factor, but also the fact that, if you have to pay for someone to come out there or you have to pay for replacement parts, because of inflation, the price of all these things are going to go up. The price in actual money is actually going to go up each year, okay? But if you do your analysis and you say that your analysis is done in terms of real dollars and real interest rates, you can kind of hand wave it to the side and say that, my analysis here is just in terms of purchasing power, not in terms of actual cash. Okay. So that's, real dollars and actual dollars. And so I'm going to throw some more vocabulary at you because, inflation has a lot of these things. And that's in terms of constant dollars and then current dollars. Okay. And so, before I start this section, I want to say that probably the most challenging thing when you're doing inflation problems is just determining, what type of money and what type of dollars are being used, because there's a lot of different terms for this. And so you might see these terms, constant dollars and then current dollars. And so let me kind of characterize these for you. Okay? And so if a problem, gives you an amount of money and says that it's in terms of constant dollars, constant dollars means basically constant purchasing power. So this means that it's in real dollars. Okay. And so there's the kind of equivalent statement there. Okay. Okay. So if the problem mentions then current dollars, this is actual dollars. Okay. And so there's kind of an equivalence there as well, okay? And so some more often ones that you might see is that if you see anything that's like time zero or year $0, so anything basically with the zero at the end of it, this is the same as real dollars. Okay. And remember, with real dollars, you always have to have a time base. And so when you're talking about the constant dollars or the time $0, the time base for these real dollars will be in terms of today. Okay.
Professor, I can't see the bottom of the paper.
Oh, the bottom of the or what's the lowest thing that you can see?
I can see then current turns to actual dollars.
Oh, and then behind, but besides that, you can't see.
I can't see like below that.
Still can't see it.
I can
Nah.
see it.
Yeah, it
Really?
might be just him.
Oh,
Just you.
Do I have to like zoom out more?
oh, I'm not sure. Yeah, I've never had that issue before. Let me go back here.
Oh, I can see it. I switched to full screen instead of side by side. That's
Oh, okay, cool. Okay. So that's time zero. So basically, if you ever see time zero or year $0, that refers to real dollars, and that's based in today's purchasing power. Okay. And then the last one that you might see is year $1. Okay. So very confusing terminology here. And so year $1 actually refers to actual dollars in year 1. Okay. Okay. And so, when you're doing these kinds of problems, you have to be kind of really careful that you kind of characterize these monies carefully. Okay? And so I'm going to do another example to kind of illustrate this and, how you can be careful and how to kind of, directly compare. Because remember, when you're doing comparisons, you want to make sure that you're comparing the right things between each other. Okay, so you don't accidentally compare real dollars in some other time frame to actual dollars, or actual dollars to actual dollars another time. So you want to make sure that everything is kind of uniform. Before I do that example, are there any questions on this? Okay. All right. So let's say that you work for an engineering company, okay, and you have a certain project that you need to get some help with. Okay, and so your engineering company is going to contract another company to do some work for you. Okay. And so after going through a list of possible vendors, you've narrowed it down to kind of to two different options. Okay. Okay. And so the first one is called Alpha Company. Right. And so Alpha Company says that they'll do their job. They'll do the job for $150,000. Okay. Okay. And this is given in terms of year $1. Okay. But because of the nature of the project, they have to increase the amount by 5% each year. Okay. Okay. And so the other company that you're considering is Beta Company. Okay. And so for Beta Company, they said that they're going to do the cost for $150,000 per year, but this is in terms of constant dollars. Okay. Okay, and so you know, of course, it kind of has to be like this because it's you know, both the companies have to be confusing. Okay, and so if you assume the project is going to last 5 years, okay, if we assume an interest rate, we assume a market interest rate of 25%. Okay, and an inflation rate of 3.5%. Okay. What we want to do is we want to solve for the present worths for both of the option in 2 different ways. Okay. Okay. And so in the first case, we're going to present the present worth in terms of constant dollar analysis. Okay. And so we're going to present the present worth in terms of you know, real terms of real dollars. Okay. Okay. And in part B, we want to present the results in terms of then current dollars. Okay. And so again, with this problem, we have an issue where, you know, both of the parts or both of the companies, you know, they're given their dollars in terms of different amounts. And so we want to make sure that we apply, first of all, we apply the correct interest rates to each one so that we can compute the correct present worth, and that we present the present worth in the correct form depending on, you know, if we want real dollars or actual dollars. Okay. Okay. Any questions on just the problem setup? Okay. Okay. And so there's a lot going on right now. So let's actually, you know, let's make a table first to kind of summarize everything that's all the costs that these companies are reporting. Okay. Okay. And so this table is just basically just to summarize, you know, what's in the problem itself. Okay? And so remember, we're going to take place. This is going to take place over 5 years. So let's write 1, 2, 3, 4, 5. Okay. Okay. And so in this first one, let's summarize the cost for Alpha Company. Okay. And remember, Alpha Company gave you their costs in terms of year 1 dollars. Okay. And we know that year 1 dollars is actual dollars. Okay. Okay. And then on the other side, you know, Beta Company gave you their costs in terms of constant dollars. And so constant dollars are real dollars in this case. Okay. And so let's summarize these costs. And so Alpha Company says that it'll be $150,000 in year 1. Okay. $150,000 in actual money. Okay. And then this price will increase by 5% each year. Okay. And so to get each subsequent price, so it's not quite the same as a gradient because the amount that it increases is going to be different each time. But we can compute this easily just by multiplying each new year by whatever it was in the previous year by 1.05. Okay, and so in year 2 we have 150,000 times 1.05, and so that's $157,000, $157,500. Okay. In the next year, if we multiply 157,500 by 5%, 1.05, we have 165,375. Okay. In year 4, we have 173,644. Okay. In year 5, we have 182,326. Okay. And so that's the cost in actual dollars. Okay. Meanwhile, Beta Company says that it's going to be a constant $150,000 each year. But remember, this is in terms of real money. Okay. Okay. And so right now, we're not actually able to compute these, or we're not able to compare these guys. Okay? And the reason we can't compare them yet is because one of them is in actual dollars and the other one is in real dollars. So if we try to compare these two guys, it's just not going to be compatible. Okay, or it's not going to be a fair comparison. Okay, and so in part A, we want to do everything in terms of real dollars. And so what we're going to do is we're going to take this first column here, and then we want to convert these to real dollars. Okay? And so if we're converting an actual amount of money to real amounts of money, remember the rule that we used to do this is we use rule 4. Okay. Okay. And rule 4 basically says that we have to apply the inflation rate to strip away some inflation. Okay. Right. So that's what I'm going to do on the next page. Okay. So remember, we have an inflation rate of 3.5%. Sorry. And so what I'm going to do is for each year, I'm going to strip away some inflation in order to get the proper real amount of money each year. Okay. Okay. So any questions on this? Okay. All right. So let's compute this away. Okay. So I'm going to summarize this in the table again. Okay. This will be the midterm of tables because there's just so many tables here. Okay. Okay. Right. So first thing I'm going to do, I'm just going to copy down the actual amounts of dollars from the previous table. So in year 1, we have $150,000. Okay. Year 2, we have 157,500. Year 3, we have 165,375. Next, we have 173,644. And year 5, we have 182,326. Okay. And remember, we want to convert these into real dollars, and the real dollars are based in today's time. Okay. Okay. And so what we're going to do is we're going to apply the inflation rate for basically, or we're going to divide by the inflation rate for however many years, has passed since today, okay? And so for year one, right? And so remember, our inflation rate is 1.35%. So we're going to strip away 1 year of inflation, okay? And so that's going to be 1.035 raised to the first power. And then in order to get the real, we're going to take our actual and then we're going to divide these guys, okay? And so what we're going to do to get the real is we're going to take the entries in the actual column, divide them by the inflation amount, and then that will give us the real amount, okay? And so in this first column right here, so the real amount for this is going to be 144,928, okay? And then the inflation amounts are going to be very similar for the next years. It's just that we raise the exponent each year because we're applying additional years of inflation each time. Okay. And so if we perform all these divisions, we get the following numbers. So we have 147, 028, okay, 149, 159, okay, 151, 321, and then 153, 514. Okay. Okay. And so what we have in this third column right here, this is the real amount of money or the real amount of purchasing power in terms of today's time that the alpha company will be presented, will cost. Okay. Okay. Any questions on how we obtain that table? Okay. All right. And so now that we have alpha company in terms of real dollars, and we already have beta company in terms of real dollars on the previous page, okay? And so now we're set to compare them, right? And so the problem actually specifically asks us to compute the present worth, okay? And so just like we have, so many times in the past, we're going to take all these cash flows here and then convert it to present day, okay? And so in order to do that, remember we need, first of all, we need the amounts of money, which is, we have that. We need the amount of time that we're going to take, which is, 5 years, so that's fine. And we also need some kind of interest rate, right? And so remember, since we're working with real money, we need to get the real interest rate. Okay. And so remember, we can compute the real interest rate from the market rate and the inflation rate. So this can be I minus F all over 1 plus F. Okay. Right. And remember, our market rate here is 25% and our inflation rate is 3.5. And so what we get from this is 20.8%. Okay. And so if we use this real interest rate along with these real cash flows that we have here in the problem, we can compute the present worths for each of them, okay? And since I'm out of room here, I'll write that on the next page. But are there any questions on this page before I turn the page? Okay. Okay, and so if we use that real interest rate and we use our real cash flows for each of them, then what we get is that the present worth for the alpha company is going to be $436,000. Okay. And then the present worth of the beta company will be worth 441,000. Okay. And so in terms of economic efficiency, it's better to go with the alpha company because it's going to cost us less, right? Because remember, the context for this problem is that we're contracting some work out to another company, and so we want to choose the one that's kind of the most economically efficient. So by $5,000, you know, Alpha Company is a little bit more efficient, although they're very close in this case. Okay. All right, so that's part A. So part A, basically, we did the whole analysis in terms of real dollars. And so we converted the actual dollars from Alpha Company into real dollars, you know, so that we can kind of directly compare them, okay? And so part B, you know, we want to do the same analysis, but instead of doing in terms of actual, real dollars, we want to do this in terms of actual dollars. Okay. And so again, you know, we're going to apply Rule 4, right? Because what we need to do is we need to convert the real dollars from Beta Company into actual dollars. Okay. And so here we're going to do kind of the opposite of what we did for the previous one. So again, you know, we're going to apply our inflation rate because remember, this is a Rule 4 type problem. But instead of dividing by it, we're going to multiply. Okay. And so let me make another table. Okay. Right. And so these are going to be for Beta Company now. Right. So Beta Company, remember, had a real cost of $150,000 each year. So we have 150,000, 150,000. And so again, we're going to have our inflation. So our inflation would be 1.35. And again, we're going to be multiplying or applying an exponent according to the number of years. And so for the first year, we have an exponent of 1. In year 2, we have an exponent of 2. In year 4, we have an exponent of 4. And then year 5, we have an exponent of 5. Okay. Right. Okay. And so remember, in this case, you know, since we're converting from real to actual, you know, we're going to be multiplying by the inflation rate instead of dividing. Okay. And so if we perform these multiplications, we have 155,250. Okay. Then 160. 284, 166, 308, 172, 128, and then 178, 153. Okay. Okay. And so, you know, now that we have the actual amounts of money for Beta Company, we can compare this and compute the present worths directly comparing that to Alpha Company. And so before we do that, let's kind of take a step back and kind of just interpret what this table is telling us, right? And so, you know, what Beta Company did was they presented their costs in terms of real money. So what they said is that, you know, the cost that it's going to take to hire Beta Company is going to be $150,000 worth of purchasing power in today's time, okay? And so what this table tells us is that the actual amount of money that we're going to need in order to have the same amount of purchasing power as $150,000 in today is going to go up each year because of inflation, okay? And so let's take year 4, for example. And so in year 4, in order to have $150,000 worth of purchasing power of today, we need $162,000 $128 in actual money in year 4 in order to have the same purchasing power of $150,000 today. And so that's what this table kind of summarizes, okay? And since, we're doing this analysis in terms of, actual money, remember, we're going to use our market rate. Okay? And so this is rule number 2, okay? And so we can use the market rate, and we can use our compound interest table to compute the present worth. So, okay. Okay. Any questions on these? Okay. Okay. And so if we actually do that, we get that the present worth of the alpha company is going to be $436,000. And the present worth of beta is going to be 441,000. Okay. And so again, we have the alpha company is superior because it's cheaper by $5,000. Okay. And so one thing that you'll probably notice is that the answers are the same as part A. Right? And so why is that? So that's not a coincidence. And so the reason they're the same is because of rule number 3. Right? And so in rule number 3, what that says is that if you have an actual amount of money and a real amount of money, and you're evaluating them at the same time frame with the same time base, these two guys are actually the same, right? And so that's exactly what we get from present worth. So in present worth, what we're saying is that a present worth of actual money today is also the same as the amount of purchasing powers that we have today, right? And so in this case, we found the present worth of both. We took a kind of a different path, for both of them, but we end up with the same answer because today, the $20 that you have in your pocket today is also $20 worth of purchasing power that you have today as well, okay? And so even though we went about this problem in kind of 2 different ways, we end up with the same result because, no matter, if you're considering them at the exact same time, then actual dollars and real dollars are the same thing. Okay. Okay. Any final questions on this example here? Okay. So that's, all the really big confusing things about, real dollars, actual dollars. So it's a bit of a brain twister, when you're kind of doing it at first. But once you kind of get the hang of it, then it becomes a bit easier. Okay. So I kind of want to take a little bit of a change of pace here and talk about something called the price index. Okay. So as you can imagine, all these things with inflations and the price of goods, this is of, extreme interest, to people who study economy, and, especially, a lot of our agencies in government that are responsible for, regulating money and stuff like that. So, these things like inflation rates and the price of goods are tracked very, very carefully, from all different kinds of agencies. Okay. And so, the way that these agencies keep track of these things is in terms of price indexes. Okay? And so price indices are important because, up until this point, for our problems, we've basically just assuming that there's just one inflation rate. Okay. And so what we've been kind of saying is that, like in the previous problem, if the inflation rate was 6%, then the price of everything goes up by 6% every year. And of course, that's kind of way too simple to kind of, summarize how complex the economy can be because, what tends to happen in reality is that, the prices of certain types of goods will go up, while others either, might stay the same or might not go enough, up as much. Okay. And so price indices are how the prices of specific types of goods are tracked through time. Okay. Okay. And so the way these work is you can kind of almost think of them as like kind of real money, right? And so when you're considering price indices, you know, there's always some kind of base time or kind of base year. Okay. And so in the base year, what it does is that, you know, in the base year, it basically looks at the price of every single type of good, and then kind of fixes it there. And then for that good, it has kind of a starting score of 100. Okay. Okay. And so what we can basically say is that, you know, in that base year, you know, this is kind of 100% of that price. Okay. And so what happens after that is that in each year after that, then the price of that good is compared to the base year. Okay. And then the ratio of the cost in the subsequent year over the cost in the base year, that gives us our price index. Okay. And so I'll give you the exact formula for it on the next page. But are there any questions on this? Okay. And so the formula for price index is going to be the cost, and we'll say that this is the price index in year N. Okay. Okay. And so it's going to be the cost of the product in year N divided by the base cost. Okay. And then we're going to multiply this by 100. Okay. Right. And so just as kind of a very quick example, so let's say that, you know, we're looking at the price of cell phones. Okay. And so let's say that in 2019, the cost of cell phones, the cost of a cell phone was $1,000. Okay. And so if we set 2019 as our base year, okay. Okay. And then we look at the price of cell phones in 2020. Okay. And so in 2020, let's say that the cost of a cell phone is now $1,100. And you know, maybe the reason for that is you have to buy a special Apple charger that's going to cost you $1,000 because it's not packaged with the iPhone anymore. Okay, and so if we compute the cost index for cell phones, then what we get is 110. Okay. Okay.
Wait, is that supposed to be times 1,000 or times 100?
Times 100. Thank you. Right, and so a price index of 110 basically says that the price increased by 10% from one year to the next. Okay. And so for the homework, you know, I actually gave you the link to the actual report that the government puts out for the price indices for, you know, all different kinds of goods. So it's a very lengthy report. So it's you know, it's I think it's maybe about 40, 50 pages long. And it really has very detailed information about how, like, the price of food or the price of, you know, healthcare, price of automobile, price of insurance, has how that all that has evolved over time. Okay, and so the base year that that report uses is 1982 to 1984. So it basically took the average prices of all goods in 1982 and 1984 between that time, and uses that as the base. And so all the price indices that you see in that report are, kind of ratios of how much the prices have increased ever since then. Okay, and so some of the things in there are actually pretty really interesting. So you'll see that like something like tobacco has a price index of like 1,000, 100 something. So that means the price of tobacco has increased by like 11 times since then, right? And it's really interesting to kind of look at and see, why has the price increased by this much over that time? And a lot of it, has to do with, either the price of, of kind of the raw materials has gone up to make that kind of product, or it could be the result of, of government regulation on their, on to kind of increase their safety or to increase, their taxes and stuff like that. Am I going to buy the new iPhone? No, I'm not. So I still have a Samsung Galaxy S8 that's been I've been very happy with, and I'm going to basically use that until it breaks down. Yeah. Yeah. Okay. Any questions on price indices? So for the homework, I want you to basically look at the price indices and to kind of pick one and to kind of maybe just conjecture. It doesn't have to be, I don't want you to do a lot of research on it, but if you see that, the price of like healthcare has gone up by, a large amount, you can kind of, try to give me a reason why you might think that that may have happened. Okay. All right. Any questions on price indices? Yeah, that report is really cool. So I know I kind of just asked you just for one thing on that question, but definitely there's a lot of really interesting information about that report, especially if you're kind of really interested in that stuff. Okay, so that's kind of the main bulk of the topics on inflation. So I want to go over just a couple wrinkles to some problems that can happen before we kind of close up this section. Okay, and so the first wrinkle that I want to go over is to consider cases where certain cash flows will inflate at different rates. Okay. And so we just got done talking about in price indices how different goods can inflate at different rates, and so we can account for this in our economic analysis. Okay, and so let's do kind of an example to kind of show how this is done, okay? And so let's say that you work for a utility company, or you work for a manufacturing facility, excuse me, and you're put in charge of estimating utility costs, okay? Okay. And so let's say that this facility is planned for 25 years of use. Okay. Okay. And then let's assume that our market interest rate is 35%. Okay. And so the three major utilities that you're going to be, that's under your consideration are electricity, water, and gas. Okay. And so, after talking to people around the facility, then you kind of have an estimate of the cost of these facilities in year $1. Okay.
That's 35%, right?
Yes, 35%. Whoa. Okay. And so in year $1, the costs are the following. So for electricity, so for electricity is going to be $55,000. For water, it's going to be $18,000. And for gas, it's going to be $38,000. Okay. Okay. And so since this analysis is planned for 25 years, it's important to know or to learn how much these utilities are going to, or how much the price of these utilities are going to inflate each year. Okay. And so the inflation rates for each of these are given by the following. Right. And this is based on, just data from the past, that you have on these guys. So you can kind of expect the prices to increase by this amount. Okay. Okay. And so electricity is going to inflate by 8.5% per year. Okay. And so water is going to inflate at 5.5% each year. Okay. Okay. And then gas is going to inflate by 6.5% per year. Okay. And so with these inflation rates, let's compute the actual yearly cost for the utilities for the first 5 years. Okay. And then let's take the present worth. Okay. And so what we're going to do is that we're going to basically, take the starting amounts of costs for each of these guys, and then inflate them by their individual amounts. And then for each year, what we're going to get is the total yearly cost for the utilities. Okay. And then from there, we can use the market rate to compute the present worth. Okay. All right. Any questions on this? Okay. Okay. So let's make ourselves the table again. Let's list it out for 5 years. Okay. And let's track the prices for each of these. Okay. So let's start with electricity. Okay. Then we have water. Then we have gas. Okay. And then we can find the total from this. And so let's write out the starting costs in the first year according to what we have on the previous page. So electricity is going to be 55,000. Water is going to be 18,000. Gas is going to be 38,000. Okay. And so if we sum this all up into the end, then we get 111,000. Okay. And then so now for each subsequent year, we're going to grow the cost for each of these guys according to their inflation rates. Okay. And so for electricity, remember our inflation rate was 8.5%. Okay. And so the price for electricity is going to go up by that amount each year. Okay. For water, our inflation rate was 5.5%. And then for our gas, our inflation rate was 6.5%. Okay. And so all the prices I'm going to list in the table from here are going to be according to their growth rates. Okay. And so I'm going to list out electricity first. So if we grow 55,000 by 8.5%, then we're left with 59,675. Okay. Then we have 64,747. Then 70,251. And then 76,222. Okay. And then for water, we're going to grow each of these by 5.5% each year. And so we grow 18,000 by 5.5%, and we get 18,990. Then 20,034. Then 21,136. And then 22,299. Okay. And then finally for gas, we're going to grow that by 6.5% each year. And so we have 38,000, grow that by 6.5%. We have 40,470, and then 43,101, okay. Then 45,902, then 48,886, okay. And then now that we have the cost for each year, we can just simply add across. And they have 119, 135, okay, 127, 882, okay, 137, 289, and then 147, 407. Okay. Okay. And so now that we have the yearly utility costs, we can convert all these to a present worth using the market rate. And then what we get from this is $273,767.80. Okay. And so this is just for the first 5 years of operation. So remember, this facility was planned for use for 25 years. And so you can easily just kind of continue this table along. Okay, any questions on this example?
I have a quick question. Are you
Yeah.
calculating the present worth for every one, or just like for the electricity and water and gas, or just like the last number, the 147?
It's just the total. So it's just the last column. Yeah. And so I think it would be a little bit hard because everything's growing at different rates. I think it'd be hard to find like a uniform series on this. And so I think just like we did with the tax calculations, I think it's easiest to consider each of these as just a single future sum, and then bring each of them back individually to the present day using a P over F factor. Yeah. Okay. Okay, so there's one more wrinkle to these problems that can happen, and that's the fact that the inflation rates can actually change over time too, right? And so it's not a constant thing. So it's not like food is going to increase by 5% each year. So it fluctuates, right? And so it fluctuates due to a lot of different factors. And so if you're doing some kind of past analysis, or you're doing some kind of future analysis, you can kind of account for this in certain ways too. So oftentimes it's really hard to predict in the future how inflation rates will be, especially unless like certain big events might be occurring. But that's something always good to keep in mind if you're taking kind of past data into account. Not only is it good to know what is the overall inflation from like 1982 to today, but how is that inflation rate change per year? Because that can kind of inform your kind of future decision making too. So I'm not going to get too much into it just because it starts to get really complicated. But I just kind of want to mention that just to kind of show you. Okay. Okay. And so before I end today, I want to show you the sign up sheet. Okay. And so remember, the sign up sheet isn't live yet. So the sign up sheet is going to go live at 11 a.m. tomorrow. But just to give you a sense of what it looks like, it looks something like this. Okay. So it's simply just gonna be a Google sheet, and the way that you sign up for it is that you go to the row for the project that you want to do with your group, and then just you put everyone's names in the groups here. Okay? So every group should have 5 members because we have 45 students divided by 9 groups. That's 45, or that's 5 students per group. Okay, and then you just sign all your names here. Okay, And so, when I open this tomorrow at 11, it's going to be a big rush to get in here. So hopefully Google Sheets doesn't shut down like, concert things always shut down, the day when tickets come open. But if you sign in here and you see that another group has signed up for the project that you want, then you got to go to your second choice or your third choice, depending on, which one that you want, okay? And so there's 15 options here. So, there should be no repeat. So every group should do something unique. And there should still be 6 left over, okay? But if you do plan on doing something else or you want to do something that I don't have listed here, definitely come talk to me, and we can get that approved. But if you want to do something from this list, then make sure, you try to have at least one person in your group sign up, when the sign up sheet gets open at 11 a.m. tomorrow, okay? Okay, any final questions on this? Okay, question in the chat. Okay. Yeah, it won't go as fast as the RTX 3090, hopefully, but you should have someone here. But just from what I've heard from the groups, I think there's some pretty diverse interests. So I haven't seen any repeats yet, but I haven't heard from a lot of the groups too. So last year there was an issue. It seemed like everyone got a project that they were happy with. So hopefully that's the same as this year. And I've added a few. Topics too as well. Okay, so if there's no more questions, that's all we got time for today. So thank you everybody for tuning in this week. The sign-up sheet will go live tomorrow, and then look forward to the study guide and the poll later today too, okay? So make sure you fill out that poll so that, you get the review session on the things that you want, right? So besides that, have a great weekend, everybody. Hope everyone has a good rest of the day, and I'll see you on Tuesday.
Professor,
Thanks,
I
guys.
have a question.
Sure, yep.
You said you're open to suggestions, right?
Yes.
On that sign-up sheet.
Mhm.
So do you want us to, instead of like writing it in there ourselves, do you want us to bring it to you first and then confirm
Yes.
if that's like a good option?
Right. Yeah. So if you're going to do something different than what's on the sign up sheet, then definitely come talk to me first. And then because a lot of the other things out there I think are good projects, but I just want to make sure that it kind of fits within kind of the confines of the project. So let's talk about it, and then I can kind of give you directions and kind of point you through a certain way, just to make sure that it's good. Yeah.
Okay. I noticed you took off, so I looked at the early version of the sign up sheet before you finalized it, and there were some options that you left off there, like going from the previous version to the final version. Did you take those off for a particular reason, or did you just kind of like save space?
Or which ones are you talking about?
One in particular I saw was Chernobyl.
Oh yes. Oh yeah, I forgot Chernobyl. Yeah, we need to add that.
Oh, okay.
Yeah, I just missed it. But yeah, Chernobyl is a very good one too. Yeah.
Okay. I was wondering if you took that off for any reason.
Yeah, I just forgot it.
Okay.
But yeah, if your group wants to do that, that's an excellent one too. So that's so if it's Chernobyl, you don't have to talk to me about that one. I know that one's a really good one. So I just added to the Google sheet, so you guys can sign up for it. Yeah.
Okay. Thank you.
Yeah.
Professor, where is the sign up for that poll?
So I haven't posted it yet. So I'm going to send the link out to everyone at 11 a.m. So I know I know a lot of people were missing from the lecture today because there was some job fair or something going on. So I want to make sure that everyone gets an even shot. So I'm going to send the link out at 11 a.m. tomorrow, and then that's when it'll open. Yeah. So not everyone in your group has to sign up, but just have, if you have one representative from your group and just sign everyone's name in there, that's good enough.
Professor, from now on, we're going to talk about ethics. We done with the economics?
Yep, we're done with economics. So we're going to be talking about ethics from here on out.
Okay, thank you.
Caleb, did you have any other?